Hello, so this is Hajjaj, and today I'm going to show you how to use PSpice software to simulate your pre-lab assignments. First of all, you need to go to the Citrix server and then find Capture CIS. I'll show you. This is my Citrix server desktop, and then you have to go to the Windows and then find Cadence. So the Cadence on the Capture CIS PSpice simulation software now. Then from Cadence folder, go to Capture CIS, click on Capture CIS, wait for it to start. It will take some time. Then open a new project here. So click on new project, then name something, let's say pre-lab 1, and then select the PSpice analog or mixed option. From the bottom of this pop-up window, go to the location, go to the browser, and then select the folder that you want to save your simulation file. Then this should be, let's say I'll save it in PLAB 1. Select the folder and click OK. Then from this pop-up window, select create blank project, click OK. Then you will have this blank project window where you will create your schematic. So first thing first, you need to know how to add the libraries. So how to add the libraries, on the right side you can see this option, place parts, right? So click on the place parts. Then I already added the libraries, but to show you, just go to the add library option, add libraries, click, then it will directly relocate you to the relocate you to the PSpice folder where all the library files are. So hit one of them and then just Control A, that will select all the library files, and then just click open. That's it. That's how you will add the library files. Now there is another option that you can use for simpler circuitries, like if you want to have only one voltage source, resistance, capacitor, or inductor, not more than that, then you have another option. You can go to the place, then PSpice components, and then from there you can select capacitor, diode, inductor, resistor, and different kind of sources like controlled source, current source, voltage source, etc. So let's start with your pre-lab 1. In pre-lab 1 you have a circuitry with the one voltage source, VAC, one capacitor, and one resistor. So let's start with the voltage source. So we have let's use this option because this is easier to find. Go to the PSpice component and then go to source and then controlled source. From there just select VC, VS, I believe. Is it this one? No, sorry, not this one. Go to place, PSpice component, source, and sign, or yes, from here just click voltage source and the sign. That is your voltage source. You can zoom, you can use escape button to go out of this selection options, and then if you want to zoom in, then just control and scroll up. That's it. That's how it will zoom in. So let's we have the voltage source, and then we need a capacitor. Again, go to the place, PSpice component, and then capacitor. So this is your capacitor. We'll change the values later. And on escape, place and PSpice component, then you need a resistance. So just a register and click Ctrl R, that will rotate your component. So we have most of the components except one, which is the most important one, which is the ground. So for the ground reference, you can have several options. So I'm gonna choose this one, place ground, click, and then select 0 source, and OK, that's your ground. Now we have to connect all the components. Use this option, place wire, and then just left click one node and another node, just like this. That's it. One more thing, connect with the ground. That's it. So now we need to, let's zoom in a little bit. So yes, now we need to change the values for all the components. Let's start with the voltage source. So V off would be 0. V amplitude 10 volt. Just press 10 or 10V, both are fine. Frequency 60 Hz, and AC just press 1, it doesn't matter. But you have to give a value for the AC. So now capacitor, in your case capacitor should be 10 microfarad, right? Just 10 U. U stands for the micro. Resistance would be 100 ohm. So if you don't give any values after any letters after the value, then it will automatically go to the default, which is the ohm. And then ground is source is already ground source is already 0, so you don't need to change anything over there. So now just go to File, Save. That's it. You already created the name, so it saved that file. Now we need to know the voltage, current, and other stuff. Before that, go to PSpice. You need to create a new simulation profile. Just select on that and name it Lab 1 or something, whatever. Create. It will show you the simulation settings. From here, according to your pre-lab, just use, let's see, run to time should be 100 millisecond. M stands for millisecond. Start setting time from 0. Maximum step size is 40. Hold on. 0.01 millisecond. Okay. So that should be it. Other than that, you need to change anything over there. Hit OK. Save it. So Control S. And then you have to place the probes to see the voltage and current. So let's start with the input voltage, capacitor voltage, and the resistance voltage. So we are going to use the voltage differential marker, this option, because this one will give you the exact value, voltage value across the component that you want to see. So first we'll click on the voltage differential marker and then place it across input voltage, capacitor voltage, and resistance, right? That's it. And I believe we also need to see the capacitor current or resistance current, because this is only one current, so one current marker will be enough. And just remember that you need to place like a current marker on the node. So let's say I will put it in here, because this is only one, all the components in a series, so there will be only one current. So place it on the top of the capacitor V plus. That's it. Escape, and then save it again and hit this Run PSpice option. So after clicking the run button, then you can see there will be another window which is a schematic of your pre-lab, and you will see all of your signals that you use the probe to see. And let's see, the green one, the first one is the input voltage source, the green one, and the red one is the capacitor voltage across the capacitor, and the blue is voltage across the resistance, and the yellow is current. Now the yellow cannot be seen properly in this window. That's because of this very small current. So I can show you one more trick that you can use. Just click on the window over here, right click, and then add plot. That will give you another plot, and in this plot you can add trace, and that will be your capacitor current, or one current. So this capacitor selection of the capacitor current should be click OK. That's your current. And now if you want to delete the bottom one, just click on the I current and then press delete. That's it. So now let's see how to measure the voltage amplitude or current amplitude. So click on the bottom plot window, and we need to see what is the voltage of the input voltage, capacitor voltage, and the resistance voltage, and what is the angle difference, and how to see that. Go to the cursor. First, it depends on which plot you want to see with the cursor. So click on that plot. Let's say I want to see the voltages first, so I'm clicking on the bottom, the cursor. So you see the red cursor, that one is showing me the green on the green voltage source, which is green voltage, which is the voltage input voltage source. Now the peak is your maximum point, and this is your value is the minimum point. And on the right bottom corner you can see when you move the cursor, the X value and the V value changes, which is the X is the X-axis value, and the V1 is the one that we are selected, that we are on right now. So let's say if we go to the maximum, that will show you the 10 volt, and if you go to the minimum, that will give you the negative 10 volt. And if you want to change the cursor to another signal, just left click on that marker. Let's say we want to select the cursor for the capacitor voltage. The capacitor voltage is this one, VC1 and C12, and just press just left click on the diamond once, and that will change, and the cursor will change for the capacitor voltage. That's how you will see the magnitude of the sources. Now the phase shift. So the phase shift, you need to see the zero crossing point, and which is the zero positive cross zero. So go to the zero crossing point of the signal when you're going from negative to positive. So let's see, just for one, we have this green one on the bottom is your input voltage source, and the red one is your capacitor voltage source, and we will measure the time delay between these two. So that time delay is basically your TD of the equation shown in your pre-lab 1. So that's how you measure the phase shift. Just use this time delay between any two signals and use that in your equation, and that will give you the phase shift between them. And how you get the time delay? So first select the input voltage 1, and then change it to the zero crossing. It's really hard to go to the exact 0 point. If you want a precise measurement, then go to zoom area and just zoom in, and from there you can see this is a almost exact 0 point. This is the zero crossing for the green one, which is the input voltage source, and then just measure the X values, which is 16.667, and then select the VC1, which is the voltage across the capacitor, and then change the same thing for the measure the same X value for the VC1, which is 17.67. So difference of this time delay is needed to measure the phase delay or phase angle between capacitor voltage and the input voltage source. So that's your PLAB 1, and I think you can measure the rest of it. Okay, good luck. This is your pre-lab assignment for the lab 1, and this is your problem 2. And here we are going to talk about the AC sweep simulation in PSpice, and how you're going to do it and how to set up the AC sweep. So first of all, you need to make the circuit, and I think if you have seen the previous video that we have posted, that should be good enough for you to make the next circuit, which is the problem 2. There is only one thing that is changed for the AC sweep, is the voltage source, and we have added another inductor. And capacitor and resistance, you know how to get it. So for the voltage source that we are going to use in here is like VAC. So if you go to the place and then go to PSpice component and source, you will see, if you go to the voltage source option, there is an AC option. Just click on that and you will get this option. You don't need to change anything else in this VAC. Just keep the default value, and other than that, like for the capacitor, inductor, and resistance, you have the value in your lab manual. Just use those values. And how to select, let's see how to select the settings for this AC sweep analyzer. So go to the PSpice and then new simulation profile. I have already made a new simulation profile. Just let me show you how to do that. Just if you click the new simulation profile, you will see you see this window where you can see analysis type. We are going to use analysis type AC sweep. Use this one. Select the logarithm here, decade, and start frequency will be 60 Hz and frequency 400 Hz, and points is up to you. If you give more points, it will take more time to simulate. I'm just using 200 points. That's it. Just you don't need to change anything else. Click apply. Okay, that's it. And then just run, and it will similarly pop up a window here. And as you don't have any probe in the circuit, you don't see anything at the beginning. So to get the impedance, that you need to see in your pre-lab 1 problem 2, the Z impedance is the impedance that your voltage source is seeing in front of it. How you get it? There is a hint in there. Just follow that hint, which is plot the voltage of the V1 divided by the current of R1 and use the function absolute and P. Absolute value is absolute value that you need, because Z is basically a complex number, so we just need to see the value of it. When you have the window, just click on it and right click on the window and click add trace. From there, on the right side, the function macros, you can see the absolute. Just click on that, and then in the bracket you can just write or select from the option. So our input voltage source is what is impedance? Impedance is the voltage source divided by current, right? So that's what we are going to do here. So we have the voltage source V1 positive. We are going to use the positive one. This is a series circuit, so we can directly use this option. Just click on this parameter V1, and then go back inside of that bracket, and then select divide, and we need the current across the resistance. Just click the current IR1. That's it, and press OK. Voila, that's your impedance of the circuit. And if you see here, the minimum impedance is when your impedance of the capacitor and impedance of the inductor is the same, right? So they are canceling each other, so you have the minimum impedance of the resistance. Of minimum impedance of the circuit, which is your resistance. Your resistance value is 100, right? So that 100, when you have only 100 impedance, that means you don't have any effect of the capacitor and the inductor over the circuit. So that's it. So the minimum point of this curve is your Z impedance at the resonant frequency. So, and which heart it is, so go to the cursor option and then just go to the minimum point. That's your 232 30 is your 230 hertz. That's your frequency when you can achieve resonant frequency. So this is your Trilab 1 problem 2. You can do the rest of it, which is the transient simulation. Just keep in mind that for the transient simulation, you need to change this voltage source and go back to your previous one, which you used in your problem 1. So okay, good luck.